What is denticity? Denticity is defined as the number of coordinating atoms present per ligand. Three types of complexes: cationic complexes, anionic complexes, neutral complexes. Coordination sphere is a single word, so it always starts by small letter. If the metal atom or metal ion surrounded by 6 ligands, the expected geometry is octahedral. Hello my dear students, I am Vidhyaashram, Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Welcome to second session of chapter Coordination Compounds. Second session of chapter Coordination Compound. In the first session, that is in the previous session, I discussed about the classification of inorganic salt, difference between double salts as well as complex salts, and different terminologies or definition required to understand the concepts of coordination compounds. As you know, the coordination compounds are also called as complex salts. Today in this session, I am going to discuss about coordination sphere, coordination polyhedron, oxidation number of central atom, table of common ligands, as well as nomenclature of coordination compounds. My dear student, don't think organic compounds only have IUPAC nomenclature. Coordination compounds also have IUPAC names. So, to name any coordination compounds by using IUPAC nomenclature, have to follow certain rules. Today in this session, I am going to discuss about how to name any coordination compound by using IUPAC nomenclature and what are the rules and regulations required to write the IUPAC name of coordination compound. Before that, you should know about what is coordination sphere. Already I explained the metal is surrounded by ligands. Metals are surrounded by ligand. The metal which is attached to the ligands enclosed in a square bracket which is known as coordination sphere. Metal atom or metal ion which is attached with several ligands which is enclosed by square bracket, that part is called as coordination sphere. The part which is present outside of the square bracket is called as ionization sphere. Therefore, my dear students, you must aware about coordination sphere as well as ionization sphere. The part which is present inside the square bracket, it is called as coordination sphere. The part which is present outside of the square bracket is called as ionization sphere. For example, when you consider K4FeCN6, K4FeCN6, FeCN6 is called as coordination sphere. 4K plus is called as what? Ionization sphere. This is about coordination sphere as well as ionization sphere. What is denticity? Denticity is defined as the number of coordinating atoms present per ligand. So, in ligand, how many coordinating atoms or donating atoms are present? That is called as denticity. These ligands which are present in a coordination compound, the arrangement in a space, and metal is fixed, it is rigid, it is present at the center. But ligands are arranged around the metal atom or metal ion in a space, give rise to definite geometry to the coordination compound. Give rise to definite geometry to the coordination compound. If the metal atom or ion is surrounded by 6 ligands, the expected geometry is octahedral. If it is surrounded by 4 ligands, it may be tetrahedral or it may be square planar. If it is surrounded by 5 ligands, either it is trigonal, bipyramidal or square pyramidal. Therefore, number of ligands, one you can decide the geometry. If the metal atom or metal ion surrounded by 6 ligands, the expected geometry is octahedral. 4 ligands tetrahedral or square planar. 5 ligands trigonal, bipyramidal or square pyramidal Now, when you consider in a coordination compound, so the central first task is you have to find out oxidation number of central metal atom or ion. Central metal atom or ion. First, we had to find out the oxidation number of central metal atom or ion. Therefore, the oxidation number of the central metal atom in a complex is defined as the charge it would carry if all the ligands are removed along with the electron pairs that are shared with the central atom. For example, what's the oxidation number of copper? Here, we had to find out oxidation state of copper, you put X. Cyanide, you know that its charge is -1. Here 4, it is -4. X minus 4 is equal to what is total charge? -3. Therefore, X is equal to 1. Therefore, oxidation state of copper in this compound is 1. Therefore, it is represented as Roman numeral copper 1 inside the parenthesis. 1 inside the parenthesis. Now, let us consider here cobalt is the central metal atom or ion, put X. Amine ligand, neutral ligand 0. Water also neutral 0. Chlorido minus 1. X minus 1, what's the total charge? Plus 2. Therefore, X is equal to plus 3. Therefore, it can be represented as cobalt, Roman number 3 inside the parenthesis. Inside the parenthesis. Here, sulfate 2 minus, therefore the charge here it is 2 plus, cobalt X, amine 0, here it is minus 2, X minus 2 is equal to plus 2, X is equal to 4, therefore cobalt 4, cobalt 4. This is how can you find out the oxidation state of central metal atom. So if you want to find out the oxidation state of any central metal atom or ion, put that as X. Then write its oxidation state of whether it is anionic ligand, cationic and neutral ligand. Already I discussed about the charge of the certain monodentate ligand, amine, H2O, CO, NO, whose charge is 0, Cl, Br, I, F, Cn, OH, acetate, this carrying minus 1, oxalato minus 2, ethylene diamine 0. So this is how do you know that was the charge carried by each ligand, and from that you should find out oxidation number of central metal atom or ion. Central metal atom or ion. Now when you consider complexes, we have already know that 3 types of complexes: cationic complexes, anionic complexes, neutral complexes. What are cationic complexes? These complexes contain at least one complex cation. If it contains complex cation, it is called as cationic complex. If it contains complex anion, it is called as anionic complex. If any complex does not carry any charge on its coordination sphere, it is called as neutral complex. This is depending upon the charge. But here once again, the complexes are classified into 2 types: homolytic complexes and heterolytic complexes. Homolytic complexes and heterolytic complexes. Homolytic complexes are those which containing same type of donor atom, only one kind of donor group or donor atom. Here observe, it contains only amine as a ligand. It contains only one kind of ligands, only one kind of ligand. Here you observe that here you have amine as well as chlorido. It has how many type of donor groups? Amine as well as chlorido. Therefore, it is called as heterolytic complexes. Therefore, before deciding homolytic as well as heterolytic, observe the molecular formula of the coordination compound. If the central metal atom is attached with only one kind of ligand, it is called as homolytic. If it is attached with 2 or more types of ligand, it is called as heterolytic. It is called as heterolytic. Now, table of common ligand. When I consider monodentate with charge 0, amine, aqua, CO, NO, pyridine, whose are neutral ligands, its charge is 0, as well as minus 1, azido, bromido, chlorido, cyanido, fluorido, hydroxido, nitrito O and nitrito N. You observe the ligand, they end with O. They end with O except neutral ligands. Except neutral ligand. Except neutral ligands, all are end with O. Minus 1, nitrito, acetato, thiocyanito, isothiocyanate. Plus, nitrosonium, nitronium, hydrogenium. So, bidentate 0, bipyridine as well as in ethylene diamine or ethane 1,2 diamine. Minus 2, carbonate, oxalato, sulfato. These having minus 2 oxidation state. So, these are the charge carried by common ligands. Charge carried by common. Observe here, except neutral ligands, all the ligands are end with suffix O. End with suffix O. It is not chloride, it is chlorido. It is not bromide, it is bromido. It is not acetate, it is the acetato. It is acetato. This is about the charge carried by common ligands. Charge carried by common ligand. For example, when there is ligand H2O comes, don't call it as water, it is call it as aqua. Na3 comes, it is called it as amine. CO, carbonyl, NO, nitrosyl. NO, nitrosyl. Now, IUPAC nomenclature of coordination compound. What's the first rule we had to follow? Any coordination compound by IUPAC nomenclature, first you had to write the name of cation, then you had to write the name of anion. Therefore, name of cation is followed by name of anion. For example, when you name NaCl, you are not going to read as chloride sodium. First you will read as sodium chloride. That means you are going to write the name of the cation, then you have to write the name of the anion. Therefore, cation is named first, next anion. When cation is named first, positively, negatively charged coordination entities. The ligands are named in alphabetical order. Ligands are always here. In case of organic compound, substituents are arranged in alphabetical order. Here ligands are arranged in alphabetical order. If there is amine, chlorido, bromido, 3 ligands are attached to the central metal atom or ion. First you have to write name of amine, next bromido, next chlorido, A, B, C, A, B, C. Then name of the ligands are end with O. The neutral ligands are not end with O. Aqua, amine, carbonyl, nitrosyl. And if the same ligand is repeat for twice, thrice or 4 times, you have to use prefixes like di, tri, tetra, penta. Okay. Now, if the complex ligands are there, complex ligands means the terms di, tri present in that ligand only. For example, this is triphenylphosphine. This is triphenylphosphine. In case of ethylene diamine, in case of EDT, ethylene diamine tetraacetate. Ethylene diamine tetraacetate, here di and tetra are repeated. These are the prefixes. And as well as in case of triphenylphosphine, prefix tri is present inside. Such ligands are known as complexes. There, if the complexes ligands are repeat for 2 times, 3 times, don't use prefixes like di, tri, tetra, etc. In that case, you have to use prefixes like bis. If 2 is present, bis, 3 is present, tris, 4 is present, tetra, kis, 4 is present, tetra, kis, 5 is present, penta, kis, 5 is present, penta, kis. This is how do you write the prefixes of complex ligand. And you have metal is present between cation present in cation and anion. When the metal is present inside the cation, just you write the name of the metal. Same metal, if it is present inside the anion, you don't write name of the metal, you write its Latin name, end with suffix ate. For example, Fe is present inside the cation, you write down iron, write down as that iron. Same Fe is present inside the anion, you should write it as ferrite. Write it as what? Ferrite. See here. Okay, write it as ferrite. So here, complex anion, the metal is named with suffix at ending. For example, CO in complex anion, it is written as cobaltate. Some metals, Latin names are used in the complex anion. Example, ferrite. These are the rules we had to apply. So name any coordination number compound according to a UPSC nomenclature. Now you have to write PT, this as neutral ligand, therefore it is 0. PT written as X, amine 0, this is -1, -1. X is equal to 2. These are 3 ligands are there, amine, chlorido, nitrito, N. First you have to write amine, chlorido, nitrito. Therefore, it is diamine, chlorido, nitrito, N, platinum 2, platinum 2. Here it is X, it is -2. Now, this is 3 plus, here you write 3 minus, X -6 is equal to -3 is equal to 3. Now it is K is potassium trioxylatochromate 3. Here Cl minus, it will become +1. X is equal to -2, 0. So therefore X is equal to 3. Dichlorido, but here it is not called as di, it is called as bis. Bis ethylene diamine cobalt 3 chloride. Here it is -1, it will become +1. X 0, it is -1 +1. It is x 0, it is -2. X -2 is equal to 1, so is equal to 3. Pentaamine carbonato cobalt 3 chloride. Pentaamine carbonato cobalt 3 chloride. This is mercury tetrathiocyanide cobaltate 3. This is tetracarbonyl nickel 0. It is -3, therefore it become +3. This is 0, 0, 0. You have to find out the oxidation state of cobalt. Therefore, oxidation state of cobalt can be written as X, X00, X is equal to 3. Triamine, triaqua, cobalt 3 chloride, cobalt 3. This is potassium tetrahydroxide zincate 2. Now here Cl3, this is 3 minus, therefore it will become 3 plus, X 0, 0, X is equal to 3. So it can be written as triamine, triaqua, chromium 3 chloride, chromium 3 chloride. See, my dear student, the name of the compound should not be start by capital letter, it starts by single letter, and name of the coordination sphere is a single word, it's a single. Don't put gap between triamine, tri, aqua, chromium. Don't put gap. It is a single word. Please write it as triamine, triaqua, chromium, 3-chloride. Observe here once again. This is 3 minus and it is 3 plus. Platinum X 0. This is minus 1. Therefore, X is equal to 4. Now it can be written as pentaamine. Pentaamine chlorido. Pentaamine chlorido platinum. Pentaamine chlorido platinum 4. Platinum 4 bromide. Platinum 4 bromide. Platinum 4 bromide. Now it is here 2 plus. Therefore it will become 2 minus. Nickel X. This is minus 4. Therefore X is equal to 2. Sodium tetrachlorido nickelate 2. Why you have to write nickelate? Nickel is present inside the anion. Now it is 4 plus, it is 4 minus. If it is X, minus 6, X is equal to 2. Potassium hexacyanide ferrate. Hexacyanide ferrate 2. Observe my dear student, coordination sphere is a single word. So it always starts by small letter. So this is how do you name coordination compound by using a UPSC nomenclature. Once again here, minus 3. This become 3 plus X 0. X is equal to 3. Hexaamine cobalt 3 chloride. Hexaamine cobalt 3 chloride. Here it is minus 1. It will become plus 1. It is X 0 minus 2. X is equal to 3. Tetraaqua dichlorido chromium 2 chloride. Chromium 2 chloride. Now it is charge is plus 2. X 0 minus 2. X is equal to 4. Tetraamine dichlorido platinum 4. The sulfate 2 minus, this is 2 plus, it is X 0 minus 1. So X is equal to 3. aqua thiocyaneto yes, iron 2 sulfate. This is tetra carbonyl nickel 0. Here it is X 0 minus 4. X is equal to 4. Diamine tetrachlorido platinum 4. Okay. Similarly, you can name all these compounds. What's the rule I apply to the organic compound? First you find out the charge. This is plus 1. This is 3 plus, that's why it is 3. This is 3 minus, therefore it is minus 1. There are already minus 2. This is 2 plus, therefore it is 2 minus. You put this as X. Find out oxidation state. It is minus 6. It is minus 4. Minus 6. Minus 4. Your oxidation state become 3. Here also 3. Here also plus 4. Here also it become 2. From the oxidation state, you can write it as potassium hexanitrito O cobalt 3. Here it is sodium tetrahydroxide aluminium 3. Here it is hexachloride platinum 4. Here potassium tetracyanide copper 2. So similarly, if you want to name any mononuclear coordination compound, whatever I told, same rules should be applied here. So central atom is listed first, the ligands are listed in the alphabetical order. So square bracket, there should be no space between the ligands and the metal, it should be one word. The charge of cation is balanced by the charge of the anion. Now I had given a list of coordination compounds with IUPAC nomenclature, my dear student. Please go through this slide. So I'll given so many coordination compound with your IUPAC nomenclature. Next, today in this session, I completed the IUPAC nomenclature of coordination compound. Next session, I am coming with what is the isomerism by coordination compound, that is structural isomerism and stereo isomerism. Therefore, until that, my dear student, goodbye. Take care, have a nice time, and go through nomenclature of a coordination compound I discussed and in one slide, as well as you refer your all NCERT textbook. Goodbye.